So Chapter 2, Measurement Part 2. Now, we introduced measurement of physical quantities and their SI units in Form 1. One very important physical quantity is length, which we measure in meters. The common instrument for measuring length is the meter rule. The most accurate ruler can measure up to a millimeter of length. This is called the least count. But in science, we need to make measurements smaller than that. Two important instruments used to measure very small lengths to a highly accurate degree is the vernier calipers and the micrometer screw gauge. We start with the vernier calipers. A vernier calipers is used to measure the length, thickness, diameter, and depth of an object and to measure the internal and external diameters of a hollow cylinder. This instrument can measure dimensions up to 0.1 millimeter or 0.01 centimeters. The two scales on the vernier calipers are the main scale and the vernier scale. The main scale is a long, thin steel strip with a jaw J1 at one end and is graduated in millimeters. The vernier scale is a graduated movable steel strip with a jaw J2 that can slide over the main scale. Generally, the vernier scale has 10 divisions marked on it. The vernier scale can be fixed at any position on the main scale with the help of a screw. The jaws J1 and J2 are parallel and projected on either side of the main scale. The lower jaws are called the outside jaws. They are generally used to measure the length or thickness of a given rod and diameter of a sphere or a cylinder. The other jaws are inside jaws and are used to measure the internal diameter of a hollow cylinder or pipe. There is a thin, long strip T1 attached to the vernier strip at the back of the main scale. This is used to measure the internal depth of a hollow tube or cylinder. The object to be measured is placed in between the lower outside jaws. Whenever we use a vernier calipers, we need to first find the least count and the zero error of the instrument. Least count of an instrument is the smallest measurement that can be recorded accurately with it. To know the smallest measurement, we must first find out the number of divisions on the vernier scale and the value of one main scale division. In this case, they are 10 and 1 millimeter respectively. Least count is then given as the value of one main scale division over the number of divisions on the vernier scale. This will be 1 millimeter over 10, which is equal to 0.1 millimeter or 0.01 centimeters. Now the zero error. Sometimes, when the movable jaw is brought in contact with the fixed jaw, the zero of the main scale does not coincide with that of the vernier scale. This is a mechanical error and is referred to as the zero error of the vernier calipers. Depending on the position of the main scale, the zero error can be positive or negative. Consider these three vernier calipers A, B, and C. In vernier calipers A, the zero of the vernier scale and that of the main scale coincide. Therefore, this calipers has no zero error. In vernier calipers B, the zero of the vernier scale is to the right of the zero of the main scale. This vernier calipers is having a positive zero error. To get the zero error of these vernier calipers, we first note the division of the vernier scale that coincides with any division on the main scale. In this case, we have 4. We then multiply this with the least count of the vernier calipers. This gives us 0.04 centimeters. The readings taken by these vernier calipers will be greater than the actual measurement by 0.04 centimeters. The vernier caliper C is having a negative zero error. To get the zero error here, first we note the division of the vernier scale that coincides with any division on the main scale. In this case, it is 6. We subtract this from the number of divisions on the vernier scale. Then we multiply this difference with the least count and assign a negative sign to the final value. So here we shall have 10 minus 6 times 0.01 centimeters. That will give us negative 0.04 centimeters. The readings obtained by these vernier calipers will be less than the actual measurement by 0.04 centimeters. After finding the least count and the zero error of the vernier calipers, we calculate the readings using the formula. Observed reading is equal to main scale reading plus the coinciding vernier scale division times the least count. 3 times 0.01 will give us 4.63 centimeters. And then we calculate the true reading. 4.63 minus the zero error, positive 0.06, and that gives us 4.57 centimeters. The next instrument is the micrometer screw gauge. A micrometer screw gauge is an instrument used to measure the diameter of a thin wire or the thickness of a metal sheet up to an accuracy of 0.001 centimeters. It has a U-shaped frame with a flat end A called the stud. There is a long cylindrical nut at the other end which is threaded from inside. In the pitch, we rotate the screw 5 times and record the distance moved by the main scale. In this case, it is 5 millimeters. The number of revolutions is equal to 5. So, H is equal to the distance moved by the thimble on the main scale over the number of revolutions. In this case, H is equal to 1 millimeter times 10 raised to power negative 3. And since this 1.0 doesn't make any difference, we often omit it. So we have times 10 raised to power negative 3 meters. Take kilometer. It says 1 kilometer is equal to 1,000 meters. We can write 1,000 in standard form as 1.0 times 10 raised to power 3. Omitting this 1.0, we have 10 raised to power 3